Hello students, this is Jagan Babu, working as an assistant professor in RMD Engineering College, Kavarapetai, in EC Department of EC. The subject is for second year EC students, art semester. Subject name is 24 EC 302 Control System. The subject is one of the important subject in the gate point of view. In previous videos I was mentioned. So each and every topic you have to correlate and sync with the previous units and upcoming units to solve the problems and to understand the fundamentals and concepts very clearly. Not only attempting for the gate, when you're trying for your NSEM question papers or when trying for your college exams, internal exams, you should clearly understand the concepts very clearly. Okay, the topic you're going to see the polar plot procedures. Previous video we had discussed only the polar plot concept. Now you see the procedures. Step number 1, replace S with j omega. You have to replace with S with j omega. So you have to take any transfer function into the frequency domain. Example, if you take g of s is equal to 1 by s into s plus 1, now the s should be replaced by j omega. That is, g of j omega is equal to 1 divided by j omega of j omega plus 1. Find magnitude. Step 2. Step 2, find magnitude. So calculate the modulus. So take modulus of g of j omega. When you take modulus of g of j omega, 1 divided by, if you take modulus, omega root of 1 plus omega square. So it gives the radius of the polar plot. Though it gives the radius of the polar plot. So I need to find the radius of the polar plot. I take the modulus, find the magnitude, I'll get the radius. That is 1 divided by omega root of 1 plus omega square. So step number 2, find the magnitude. You need to take modulus, where modulus of g of j omega is equal to 1 divided by, from the step number 1, g of j omega 1 by j omega of 1 plus j omega. In step 2, you take modulus. So 1 divided by omega root of 1 plus omega square. From the step number 1, you are just replacing s by j omega. That's the frequency response curve. In step number 2, when take the modulus, what is the output you're going to see? This gives the radius of the polar plot. Step 3, find the phase angle. So calculate the angle. So angle of g of j omega. Once magnitude over default, you need to find the phase angle. Angle of g of j omega, which is equal to 90 degree minus tan inverse of omega. 90 degree minus tan inverse of omega. It gives the angular position. It shows the angular position. Substitute the different values of omega. You need to substitute the different values of the omega. Suppose I'm taking the value as 1 as 0, 1 as 1, directly other is infinity. 3 different values I'm taking, 0, 1 and infinity. Now find the magnitude and phase of the particular values. So find the magnitude and phase. So take the omega value, take the magnitude value, take the phase value. When you focus on the omega value 0, 1, infinity, you'll get the magnitude for 0 is infinity, for 1 is 0.707, for infinity it is 0. This is the magnitude, right? When you substitute like this, when I put 0, it's 1 by 0 is infinity. When I put 1, 1, so 1 plus 1, 2. 1 by root 2, 0.707. When I put infinity, total term is 0. Then come to phase angle. Accordingly, you will get minus 90, minus 35, minus 180. So 0 means directly minus 180. 0.707 1 by root 2 means minus 135. Infinity, minus 90 degree. Step number 5, plot the points on the polar plane. You need to plot the plots in the polar plane. That is, radius is equal to magnitude, angle equal to plane. We both mentioned here. Radius equal to magnitude, angle is equal to angle, phase angle. Join all the points smoothly, indicate increasing omega direction using arrows. So when you have the part after the plotting, you need to connect over this, you have to complete the polar plot. Hope you understand this polar plot procedure. Thank you, students.